My name is Dr. Abrahamian, and in this channel I go over problem solving strategies mainly in math competitions. This is a problem from 2024 International Math Olympiad. This is a shortlisted problem. So shortlisted problem A3. Decide whether for every sequence an of positive reals, this expression is less than 1 over 2024 for at least one positive integer n. And I'm going to walk you through the process by which I obtained the solution. The first thing that I did was I'm going to take this 1 over 2024 and I'm going to set that as epsilon because the answer is probably not going to depend on what this number 1 over 2024 is. It's just a small positive number. It's probably either going to be true for every epsilon positive or it's going to be false for every epsilon positive. Very likely. Now, we're going to try to create a sequence that doesn't satisfy this and see what goes wrong. And if it goes wrong, then we know that the answer is yes. And if we can create that sequence, then the answer is no. So we want the sequence that 3 to the power of a1 all the way to the power of an over 2 to the power of a1 all the way to 2 to the power of an squared is greater than or equal to epsilon. Okay, so the first thing that I did was I see a Cauchy-Schwarz inequality here that can be applied. Let's apply that and see what we get. So we have 3 to the power of a1 plus 3 to the power of an. If I multiply that by some other expression, I would get on the other side 2 to the power of a1 all the way to 2 to the power of an squared. So I'm going to take a sequence here that when I multiply that, I would get a square of 2. So I would get 4 over 3 to the power of a1. So if I multiply these two, I would get 4 to the power of a1, and then square root of that would give me this. So we get 4 over 3 to the power of an. So that means the expression that I have, which is 3 to the power of a1 all the way to 3 to the power of an over 2 to the power of a1 all the way to 2 to the power of an squared is going to be greater than or equal to 1 over 4/3 to the power of a1 all the way to 4/3 to the power of an. And this expression is in fact more than 1 over n because each of these terms in the denominator are more than 1. So this is more than 1 over n, which approaches 0. So we cannot make this one greater than or equal to epsilon. So this didn't really work. So now let's try and see if I can create a sequence by taking extreme cases. So what are the extreme cases? We can take a1 through an to be very close to 0. If we do so, we're going to get 3 to the power of 0 roughly all the way to 3 to the power of 0 and 2 to the power of 0, which gives me n on top and n squared at the bottom. That's also 1 over n, and that is going to approach 0, so I cannot make this one greater than or equal to epsilon either. Now the other end of the spectrum would be if I take an and I allow it to go to infinity. That would be the other extreme case. If I look at the fraction, well, I can approximate the numerator and denominator by looking at the extreme cases. So what are the extreme cases? The dominant term in the numerator is 3 to the power of maximum of a1 through an. And the dominant term in the denominator is 2 to the power of maximum of a1 through an squared. So this is 3/4 to the power of maximum, which does go to 0 as well. So any of these approaches is not going to give me a sequence that remains away from 0. So I decided maybe I can make this one more rigorous and see if I can make this one less than 3/4 to the power of maximum, or I can approximate it with that, and then hopefully I can show that it can be always less than epsilon, or I can create a sequence. So this is an idea that you have seen if you have taken a course in calculus. You have seen in a course in calculus. So let's say you want to find the limit of 2n squared plus 3n plus 1 over 5n squared minus 3n plus 7. Something like this as n goes to infinity. So how do you find the limit of this? What you do is you factor the leading term. So 2 to the power of n, 2n squared and 5n squared are going to be factored. So we get 1 plus 3 over 2n plus 1 over 2n squared, and then 1 minus 3 over 5n plus 7 over 5n squared. And that allows me to approximate the numerator by the leading term and the denominator by the leading term, because these quantities, these four quantities, all go to 0, which means the limit is in fact 2/5. So I can approximate the fractions by their dominant terms by factoring them. So let's do the same thing in this fraction that we are given. So we have 3 to the power of a1 through 3 to the power of an divided by 2 to the power of a1 all the way to 2 to the power of an squared. So what is the dominant term in the numerator and the denominator? The dominant term are the largest exponent. So let's call that m sub n to be the maximum of a1 through an. So if I factor that, I get 3 to the power of n times 3 to the power of a1 minus mn all the way to 3 to the power of an minus mn divided by, if I factor the same thing because of this square, I would get 4 to the power of mn and then 2 to the power of a1 minus mn plus 2 to the power of an minus mn squared. Now, this is only going to be helpful if mn approaches infinity. If I have a sequence that kind of tends to infinity, it doesn't have to be a sequence that approaches infinity. It would be a sequence that it could oscillate, but at some point it is unbounded. It does blow up. So let's see how I can compare these two. Well, I'm going to keep this because these are the dominant terms, and I'm going to see if I can control those terms. It is very different from the situation that I have here. In this situation, I have lots of terms that are all small, but I can't really say these terms are small because I don't know what the sequence is. I do know that in this sequence, these exponents are the same. These exponents for the corresponding terms are the same. And each of these ak minus mn is less than or equal to 0. So that means 3 to the power of ak minus m sub n is in fact less than or equal to 2 to the power of ak minus m sub n. What does it mean? It means if I look at this fraction, let's call this r sub n. If I look at the fraction Rn, I would get 3/4 m sub n, and then I get 3 to the power of a1 minus m sub n all the way to 3 to the power of an minus m sub n over 2 to the power of a1 minus m sub n all the way to 2 to the power of an minus m sub n. This fraction is going to be less than 0. The reason being, each of the terms, corresponding terms, are comparable. You can say that 3 to the power of ak minus mn is less than or equal to 2 to the power of ak minus mn. Now we are left with one more term here. We have 2 to the power of a1 minus mn all the way to 2 to the power of an minus mn. Now if you look at this fraction, that fraction is also less than or equal to 1. Why? Because one of these terms is going to be, one of these terms at the bottom is going to be 2 to the power of mn minus mn, because mn is the maximum, so it does appear at the bottom. So this Rn, which is the sequence that they gave us, is in fact less than or equal to 3/4 to the power of mn. So now, if this mn goes to infinity, so there are two cases. Case 1 is mn goes to infinity. In other words, for every c positive that you take, there is some n such that an is greater than this c. Then Rn is less than 3/4 to the power of mn can be made less than epsilon by choosing mn to be greater than log of epsilon over 3/4, which we know is possible because of the assumption. So the second case is, so there is some positive c such that an is less than c for every n. If that is the case, then I have to treat this a little bit differently, because 3/4 to the power of mn doesn't go to 0. 3 to the power of a1 all the way to 3 to the power of an over 2 to the power of a1 all the way to 2 to the power of an squared. This is less than, I can say each of the numerator terms in the numerator is less than 3 to the power of c, and each of the terms in the denominator is more than 1. So we get this fraction, 3 to the power of c over n. And of course, we can make this one less than epsilon as well by making sure that n is more than 3 to the power of c over epsilon. So in other words, the answer to the problem is yes. There is always some n that fraction is less than epsilon. And that brings me to the end of this video. So I will see you in the next video.